we rely on automated systems for, well, pretty much everything these days. I mean, you ask an artificial intelligence a question, it hands you a fact, and you probably just take it at face value.
Right, yeah, you just assume the machine has done the math, it checked the records, and it arrived at the truth.
Exactly.
Yeah.
But I want you to imagine a scenario for a second. Imagine you're doing some critical research. Maybe you are finalizing a legal brief or writing a thesis, and the AI gives you a very specific date for an important historical event.
Okay, so you write it down.
You write it down. You build your entire argument around it, and then right in front of your eyes, on the screen, that date just flickers.
Oh, wow.
Yeah, just a quick visual glitch. And suddenly, it's a completely different date.
See, that right there shatters the entire illusion of certainty. Because when a machine alters its output in real time like that, you're immediately forced to confront the fact that you're dealing with a probabilistic engine. It's not a static encyclopedia.
Right. It makes you question every single interaction you've ever had with the tool.
Yeah.
Like, was that first date a hallucination? Is the second date just a slightly better guess?
Or did a human engineer behind the scenes step in and manually change it?
Exactly. How are you supposed to build any kind of professional trust in an automated system when the machine literally changes its mind while you're looking at it? And that is the exact mission of our deep dive today.
It is, yeah. We're exploring a brilliant, highly allegorical tech blog post by a software engineer and writer named Aaron Rose. It's titled The Secret Life of Azure, the Audit Trail.
And Rose takes a really unique narrative approach here to explain some notoriously dry concepts, right? Like AI, traceability, cryptographic logging, compliance.
Which can be incredibly dense topics.
So dense. But instead of setting this discussion in a sterile modern server farm with blinking blue lights, he sets the entire story inside a grand, incredibly atmospheric Victorian library in London.
I love that choice. The setting does so much heavy lifting for the concepts.
It really does. Throughout the piece, instead of server racks, you have these towering, labyrinthine oak bookshelves. You can practically smell the old paper, you know, the floor wax, the gas lamps.
Yeah, it's this perfectly analog representation of a digital world. And in this library, code quality isn't just some metric on a dashboard. It's an unspoken objective. Craftsmanship is the only thing that matters.
Right. And we follow two main characters in this library. This is actually episode 38 in Rose's ongoing narrative series, by the way.
Yep, we have Margaret, who is a wise, veteran, senior software engineer.
Always armed with her signature scarlet marker.
Exactly. And we have Timothy, her junior colleague, who is basically just trying to learn the architecture of this vast system. And this particular installment kicks off with a rather intense confrontation.
It does. The inciting incident drops us right into the tension. A senior researcher storms into Timothy's office, and this researcher is visibly annoyed.
Just furious.
Right. They're pointing to a corrected citation in their bibliography. And they tell Timothy that the library system provided a date, then it flickered, and now the date is entirely different.
And the researcher demands to know why it changed, who changed it, and most importantly, whether this was a machine's random recalibration or an actual human being's decree.
Yeah, the researcher looks at Timothy and says, I can't cite a flicker.
What's fascinating here is Margaret's immediate realization of what this frustration actually represents. She uncaps her scarlet marker and tells Timothy that the researcher is entirely justified in their anger.
Because trust isn't just about being right anymore.
Exactly. Being right is no longer enough. The system has to be auditable. Margaret explains that the tech industry is being forced to move away from an era of hidden review.
Where the machine thinks in a black box.
Right, and step into an era of immutable traceability.
Okay, let's unpack this, because Margaret's realization of immutable traceability sounds great as a corporate buzzword, but I'm looking at it from Timothy's perspective.
Sure.
If the AI needs a way to prove it isn't just hallucinating, or secretly rewriting its own history to cover its tracks, what stops a skeptical user from assuming that Timothy just went into the back end and edited the log after the fact?
Timothy literally raises this exact point. He asks what stops someone from assuming he just altered the records to make himself or the machine look competent. It's the oldest problem in system administration. Who watches the watchers?
Right. If you have the keys to the database, you can rewrite history.
Exactly. But Margaret's solution to this is a mechanism she calls the Scarlet Ledger, which is Rose's allegory for immutable audit logs. And the way she secures this ledger from tampering, even from Timothy, is through cryptographic hashing.
Okay, so I understand the concept of a secure password, but how does cryptographic hashing actually prevent someone from altering a historical log?
Well, think of a cryptographic hash as a unique mathematical fingerprint for a specific piece of text. When the AI makes a decision, that decision is recorded as an entry in the ledger. And then an algorithm generates a unique string of characters, the hash, based on the exact contents of that entry. But the crucial mechanism here is that the hash of the next entry must include the hash of the previous entry.
Oh, I see. So they interlock.
Precisely. They are mathematically chained together. So if Timothy were to go back to an entry from 3 weeks ago and change a single comma to cover up an AI mistake.
The fingerprint changes.
Yes, the mathematical fingerprint of that specific entry would instantly change. And because it changed, the next entry's hash, which relied on the original fingerprint, would break.
Wow. So the whole chain just shatters.
Exactly. The entire chain of subsequent logs would shatter, instantly alerting the system that the history had been tampered with. This creates an append-only store. You can add new lines to the bottom of the ledger, but absolutely no one can go back and alter a line that has already been written.
Not the AI, not Timothy, not even Margaret with her scarlet marker.
Nobody.
You know, when I was reading this, the analogy that immediately sprang to mind was an airplane's black box, like the flight data recorder.
Oh, that's a great way to look at it.
Right. A plane might hit severe turbulence, the autopilot might disengage, or worse, but that indestructible orange box is recording every single variable permanently. The altitude changes, the pilot inputs, the hydraulic pressure shifts.
And Margaret uses almost that exact phrasing in the text. She calls the Scarlet Ledger the flight recorder for the library's intelligence.
It's just a perfect comparison. Because the Scarlet Ledger doesn't just record the final answer the AI gave the user, does it?
No, it records the raw initial output. It records the internal red flags raised by the system's evaluator node. It records the final sign-off from the librarian node.
It takes the AI out of the black box and puts it into a glass box.
Yes, where every micro-decision is visible and permanent.
Here's where it gets really interesting. Because the moment you build a perfectly secure permanent flight recorder that captures every single interaction a user has with an AI, you stumble into a massive new problem.
The privacy issue.
Exactly. If we are permanently recording every single prompt, every single query, every single output, haven't we just created the ultimate surveillance nightmare?
It's a huge concern.
Think about it from your perspective as the listener. What if you ask an AI a highly sensitive medical question? Or an embarrassing personal query. Or you feed it proprietary business data to summarize.
Is that permanently etched into the Scarlet Ledger for any database engineer to read?
Right. How do we prove what happened without completely violating the privacy of who made it happen?
This raises an important question, and it is arguably the central tension in modern data engineering, the friction between total transparency and individual privacy.
So how does Margaret handle that in the library?
She addresses this head-on by introducing PII redaction into the architecture of the Scarlet Ledger.
PII meaning personally identifiable information.
Correct.
But how do you strip that out reliably when you're dealing with conversational AI? It isn't like deleting a column in a spreadsheet. People speak to AI in messy natural language.
That is the technical hurdle. You might type, "My name is John, I live at 123 Main Street, and I need help analyzing this financial document."
Right.
To solve this, Margaret explains that before anything is ever allowed to hit the permanent immutable ledger, it must pass through an aggressive privacy filter.
Like a machine learning filter.
Exactly. This filter uses machine learning to identify and mask personal identifiers like names, addresses, specific user secrets, email handles, all before the log is hashed and sealed.
It reminds me of having a security camera inside the library. Say it's programmed to track how a book is moved from the reference section to a study table. But the camera software automatically blurs out the faces of the patrons moving the books.
That captures the dynamic perfectly.
It records the mechanics of the system working, but it fundamentally separates the action from the identity of the actor.
Yes. And the text explicitly points out that this redaction layer is how they maintain compliance with strict privacy regulations, like GDPR.
So you get accountability without surveillance.
Right. You get total accountability over the machine's internal logic without extending that surveillance to the human beings utilizing the machine. The chain of custody for the library's intelligence is maintained, but the reader's privacy remains absolute.
All right, so Timothy and Margaret have engineered a perfectly secure, mathematically unhackable, completely anonymized cryptographic log. The Scarlet Ledger is functioning beautifully.
A technical marvel.
But that brings us to the next massive logical hurdle. Remember the deeply annoyed researcher from the beginning of the story, the one frustrated by the flickering date?
The historian.
Yes, that researcher is a historian, not a database engineer. If Timothy hands them a raw, cryptographically hashed JSON file from an Azure server, it's going to look like absolute gibberish.
Just walls of code and alphanumeric strings.
Exactly. How do we translate this highly technical, secure ledger into something a human user can actually read, understand, and use to rebuild their trust in the system?
Because raw data, no matter how secure, is basically useless if it cannot be interpreted by the end user. To bridge this gap, Margaret details two specific user-facing solutions in the text. Source metadata, which she visualizes as the provenance map, and an explainability UI.
I want to dig into the provenance map because Timothy asks a really vital question here. He asks Margaret, what happens if the original source the AI used to pull the fact was wrong in the first place?
Right. If the AI perfectly retrieves a flawed document, the answer is still wrong.
Exactly.
And Margaret's response gets to the core of auditable AI. She explains that if the source was wrong, the log captures that reliance. She draws a visual web stretching from the user's desk all the way back to the physical library shelves to illustrate provenance tracking.
The system tracks the source metadata. It isn't just saying, here's the fact. It's providing a detailed map.
Right. And that map includes the document's last verified date and its authority score.
Now, I'm curious about that authority score. How does an automated system judge the authority of a text?
Well, in the context of the piece, an authority score is essentially a metric of trustworthiness calculated by the system. It's based on factors like the age of the source, how often it has been peer-reviewed or cross-referenced, and its historical reliability within the library's network.
So it's basically showing its receipts.
Exactly. By surfacing this score and the provenance map, the system isn't demanding blind faith. It's giving the researcher the exact origin of the fact so they can evaluate the source material themselves.
And that leads right into the explainability UI. Margaret draws a little magnifying glass icon to represent this feature. And to me, this felt exactly like a high school math test.
Oh, how so?
Well, you remember taking those algebra exams, right? You get the final answer perfectly correct. Maybe the answer is 42, but the teacher would still give you a failing grade if you didn't show your work.
Oh, absolutely. The red ink.
Right. They don't just want the output. They need to see the red ink on the page showing the steps you took to isolate the variable.
Yeah.
They need proof that you understand the underlying logic and didn't just, guess or copy the kid sitting next to you.
That is the exact philosophy behind the explainability UI. For every high-stakes response the system generates, it provides a literal show your work button represented by that magnifying glass.
And what happens when you click it?
When the user clicks it, the UI queries that complex cryptic audit trail and translates those cryptographic hashes and system flags into a simple, human-readable narrative.
The text gives a fantastic example of how this translation looks. When you click the magnifying glass, instead of seeing code, you see a clear sentence. Quote, "The lead planner suggested X, the evaluator flagged Y, and the librarian verified Z using document A."
It entirely removes the mystery. It actively displays the internal debate the machine had with itself before it finalized the output.
It's so elegant.
It really is. And Margaret emphasizes the philosophical weight of this design choice with a wonderful quote. She tells Timothy, "Transparency is the antidote to skepticism. By actively showing the internal workings and the internal corrections, you invite the user into the process of verification."
So what does this all mean for the physical space of the library? Or I guess in real-world terms, the server space. Because if we are storing the detailed show your work steps for every single AI interaction.
And storing it forever.
Right, in an append-only ledger where not a single comma can ever be overwritten. This grand Victorian library is going to run out of shelf space incredibly fast.
It is a massive scaling issue.
Now, I know the common pushback here.
Yeah.
People say storage is cheap in the digital age. Server space is practically infinite. But if storage is so cheap, why delete anything at all?
Well,
Like, what if a legal researcher or a medical professional needs to verify a life-or-death AI decision from 15 years ago?
yeah.
Why not just hoard the logs permanently?
That is a very common assumption, but Margaret introduces a strict retention policy to counter it. She draws a timeline to explain the mechanics of memory, operating on the principle that, as she puts it, forever seems expensive.
And she doesn't just mean money, does she?
No, not just the financial cost of hard drives. She is talking about computational overhead, the processing power required to search through decades of irrelevant data.
Oh, right. It would slow everything down.
Exactly. She's also talking about legal liability. In the real world, holding on to unnecessary data indefinitely is a massive risk during legal discovery or a data breach.
So how does she structure the timeline to balance accountability with the cost of memory?
She implements automated, rigid schedules. For routine debugging, everyday queries, minor system operations, standard web searches, the logs are kept for 90 days.
Which is enough to catch immediate bugs.
Right. It provides enough of a window to catch immediate bugs or user complaints. But for compliance-critical decisions, like the legal or medical research scenarios you mentioned, the retention period is extended to a hard 7 years.
And after that?
After those specific timelines expire, the logs are automatically and permanently purged from the ledger.
Automatically purged.
If we connect this to the bigger picture, actually, Margaret has a brilliant phrasing to summarize this exact policy. She tells Timothy, "The Scarlet Ledger has a memory, but it's not a hoarder."
That is such a profoundly human way to describe database lifecycle management.
Isn't it? You keep what is absolutely necessary for accountability, but you build in a mechanism to let go of the rest so the system doesn't eventually drown in the weight of its own past.
It highlights that building a trustworthy system requires deliberate, purposeful curation, not just endless data accumulation. And, this brings us full circle back to the narrative resolution between Timothy and the annoyed researcher.
A historian who couldn't cite a flicker.
Exactly. Timothy has successfully built the Scarlet Ledger. He has implemented the PII redaction filters, the provenance mapping, the human-readable UI, and the retention policies. And he finally sits down and opens the log for the historian.
This is where the theoretical architecture finally meets the human user.
Right. Timothy doesn't just ask the researcher to trust the machine. He clicks the magnifying glass and shows them the exact, verified sequence of events.
Step by step.
Step by step. He shows them the original hallucination the AI generated. He shows them the scarlet flag from the internal evaluator node that caught the hallucination in milliseconds. And finally, he shows them the specific 17th century manuscript that the librarian node used to verify and correct the date.
It is all laid out in the log, entirely transparent.
And the reaction from the researcher completely validates Margaret's approach. The annoyance and the feeling of being gaslit by the machine just vanishes.
It's replaced, as Rose notes in the text, by a deep scholarly respect.
The researcher looks at the detailed log and admits, "I don't mind the correction, now that I can see the proof." That flicker wasn't an error. It was the system working exactly as intended.
It was the system catching a mistake and fixing it. And now there was an immutable receipt to prove it.
Timothy has this profound moment of realization as he looks at the ledger. He says that the library doesn't just have a memory now. It has a conscience.
A conscience. Personifying an audit trail as a conscience implies that the system is now capable of self-reflection. It's bound by a verifiable code of conduct.
Yeah.
And Margaret caps her scarlet marker with what is arguably the defining quote of the entire piece. Trust is built in the dark, but it's proven in the light of the log.
Proved in the light of the log. That concept perfectly distills everything we've explored today. The complex algorithms, the massive data crunching, the vector searches, that all happens in the dark, inside the black box of the machine.
Right.
But the trust from the human user is only earned when you drag those internal decisions out into the light and make them fully auditable. So bringing this directly back to you, the listener, the next time you are using an AI tool, whether you're writing code, doing historical research, or asking a model to summarize a dense report and it confidently hands you a fact, ask yourself a question. Where is the audit trail?
Where is the ledger?
Can this machine show you its work, or is it demanding that you operate on blind faith?
And that leads to one final, somewhat provocative thought for you to mull over as we wrap up. We are rapidly moving toward a future where AI systems will be legally required to maintain these perfect, immutable audit logs.
Oh, have to.
They will have to show exactly how they arrived at every single answer to satisfy strict compliance regulations. But there is a psychological phenomenon known as the Hawthorne effect.
Oh, right.
Which states that individuals alter their behavior when they know they are being observed.
Right, like an employee working harder when the boss walks by.
Exactly. So if an AI model knows, in a computational sense, that every internal step it takes is being permanently recorded and audited by humans, will future models start optimizing their internal thought processes just to look good on the audit report? Will they begin choosing the safest, most easily explainable, heavily documented path, rather than taking a leap to find the absolute best, most creative, or most nuanced answer? When the ledger is always watching, does the fundamental nature of the intelligence itself begin to change?
Wow. Does the surveillance actually change the behavior of the machine? Do we trade creativity for compliance? That is a massive question to take away from this. We went from a simple flickering date on a bibliography to questioning the future psychology of artificial intelligence under observation. Thank you so much for joining us on this deep dive into the world of audit trails, scarlet ledgers, and the mechanics of trust. Keep questioning the black boxes, keep looking for the light of the log, and we will catch you next time.